Let's see the question. A solid cylinder of density rho naught, cross-sectional area A and length L, floats in a liquid of density rho with its axis vertical. If it is slightly pushed downward and then released, the time period will be. So which option will be the answer? So let us see how you will solve all this problem. Just imagine that this is the liquid and this is basically the cylinder. Now consider some applied force is acting on the cylinder. As a result, its displacement towards the liquid is x. Let us consider x is the displacement of the cylinder inside the liquid due to this applied force. So what is the direction of displacement here? This is the direction of displacement. So now due to this displacement, some buoyancy force will act on this cylinder. The buoyancy force acting on the cylinder due to its displacement inside the liquid, due to its displacement inside the liquid is F equal to minus m prime g. M prime is the mass of the displaced liquid. So how we will calculate m prime? According to Archimedes, the volume of the displaced liquid will be equal to the volume of the object that is immersed inside it. So what is the volume of the displaced liquid? The volume of the displaced liquid is exactly equal to the volume of the object that is immersed inside it. So if we know the volume of the displaced liquid, then easily we can calculate the mass of the displaced liquid. And why we take this negative sign, sir? Because the displacement is in the downward direction and the buoyancy force that will act on the cylinder, it will basically act in the upward direction. Since displacement and buoyancy force that is acting on the cylinder is basically opposite to each other, that is why we take the negative sign here. So what we will do here, m prime is basically mass of the displaced liquid. So how we will calculate m prime? I think we all know m prime equal to ax into rho, because rho is the density of the liquid. So from that formula, F will be minus ax rho g, and from Newton's second law we also know F equal to ma is equal to minus ax rho g, where this m is basically the mass of the entire cylinder. Mass of the entire cylinder. M is basically Al rho naught, because m is the mass of the cylinder, volume of the cylinder is Al, and if we multiply the volume with the density, then we will get the mass. So ax rho into A is acceleration minus ax rho g. So A will cancel each other, so it will be L rho naught into d2x dt2 plus x rho g is equal to 0. Then L rho naught d2x dt2 plus rho g into x equal to 0. So we can write d2x dt2 plus rho g by L rho naught into x equal to 0. We can also write it d2x dt2 plus omega square x equal to 0. This is the general form of simple harmonic motion, or SHM. So this shows that the cylinder will execute simple harmonic motion, where omega square is equal to rho g by L rho naught. So omega equal to root over rho g by L rho naught. So time period t will be 2 pi by omega. So 2 pi root over L rho naught by rho g. So that will be the time period L rho naught by rho g. So this is the final answer. Now I will give you another numerical on the basis of same concept. It will be your homework. That is your homework. You can solve it on the basis of same concept. That's it.